Hi students, welcome to my channel. In previous video we discussed what is the reason of learning an AVL tree. Now in this video we are going to discuss how to balance a binary search tree. So here we discussed already AVL tree is also called as a height balanced binary search tree. Okay, so now how to balance the binary search tree we will discuss in this video. Okay, so now how to balance the binary search tree. Of course, that balanced binary search tree we will call it as an AVL tree. So how to balance this? So for each and every node we have to calculate balance factor. So if a tree is there, binary search tree is there, for that binary search tree at each and every node, we have to calculate the balance factor. What is this balance factor? Balance factor is the difference between heights of left subtree, difference, height of right subtree is the balance factor. Okay, for one node you have calculated this balance factor. If that is equal to -1 or 0 or +1, then that tree is, so for each and every node, if the balance factor is -1, 0 or +1, then that binary search tree we can call it as an AVL tree. Okay. Now, what is an AVL full form is scientist names Adelson-Velsky and Landis is the scientist name. Okay, two scientists invented this AVL tree. Okay, so now at each and every node, if the balance factors are -1, 0, +1, then that is called as an AVL tree. For example, so now this is the binary search tree. Consider the binary search tree. For example, 28, 19, 34, 12, then 25. For example, this is the binary search tree. Let us check what is the balance factor at each and every node. We will calculate it. So how to calculate it? So the difference between heights of left subtree and right subtree. I am telling you a simple manner. Okay, if it is a leaf node, consider that balance factor is 0. I am telling you easy trick. Okay, so if the node is a leaf node, balance factor is 0. Okay, now and remember these balance factors we have to calculate from leaf node to bottom 2, that means root node, that means leaf nodes to root node we have to calculate. Okay, so for 19, what is the balance factor? What is the height of left subtree? 1. What is the height of right subtree? 1. 1 minus 1 equal to 0. Next, this one already we have done. Next, 28. What is the height of left subtree? See, here it is 1 and 2. So height of left subtree is 2. Then height of right subtree is here only 1, which is equal to 1. Now see what are the balance factors for all these nodes. So for some nodes it is 0, for some nodes here it is 1. See, if the balance factor is -1, 0 or +1, then that tree is called as an AVL tree. So this binary search tree is a balanced binary search tree, height balanced binary search tree. Okay, so now take another example. Suppose the tree is 32, 25, 39, 35, 60, For example, here it is right side now. So 28 for this left side. So 26 for example. Now it is a binary search tree. Observe. So all left subtree elements are less than 32 and this is greater than 25. And here it is right side 39, 39 left 35, 39 right 60. Okay. Yeah, it is a binary search tree. Now let us verify is it an AVL tree or not. Okay. So now for an AVL tree, what should we calculate? We have to calculate balance factor at each and every node. Okay. So now 26 is a leaf node 0, 35 it is a leaf node 0, 60 it is a leaf node 0. Okay. So after finding or after writing leaf nodes balance factors, now come to non-leaf nodes. What I said, from bottom to top we have to calculate the balance factors. Now for 28, so height of left subtree is 1. Height of right subtree, there is no height of right subtree, it is 0. So now balance factor here it is 1 at node 28. Balance factor at node 28 is 1. Okay. So next balance factor at node 25 we will calculate. Next balance factor at node 32 we will calculate. Next balance factor at node 39 we will calculate. Okay. Already balance factors at the node 26 already we have calculated, 35 already we have calculated, 60 already we have calculated. Okay. Now come to for the node 25. So is there any left subtree for node 25? No, consider it as 0. Now right subtree height. Right subtree height is, don't consider only this one. Right, this is your complete right subtree for 28. Okay, then what is the height at 25 for the right subtree? It is 2. 0 minus 2 which is equal to minus 2. At node 25 the balance factor is minus 2. Remember one important point. Here you got the balance factor is minus 2 which is invalid balance factor for an AVL tree. Then you can stop the process of calculating balance factors for this and you can conclude it as it is not an AVL tree. Okay, so at one point you got other than minus 1, 0 plus 1. Then you can stop the process. You can conclude that the tree is not balanced. Why? Because we got the balance factor as minus 2. Okay, but for so here already we can identified that this is not an AVL tree, but we will calculate the balance factors for these two nodes also. Okay, not these two, for these two, 32 and 39. So first we will calculate the balance factor for 39. 39 balance factor, left subtree height is 0, right subtree height is 0. 0 minus 0, 0. Okay, 39, 0. So 32, see left subtree height. Left subtree height is 1, 2, 3. Left subtree means it is not like this only. The entire left subtree you have to consider. So 1, this is 2 and this is 3. So here it is left subtree height is 3. Right subtree height 1, 2. 3 minus 2 equal to 1. Okay. So for 32 balance factor is 1. What you have observed? Though you have calculated balance factors for these two nodes, there is no use. Why? Because these are satisfying AVL tree property. But here the property is failed. So you can say that the given binary search tree is not a AVL tree. Now example 3. So consider this as our last example. Now suppose the tree is 49, 40, it should be greater than 40, so it is 45, and here it is 45 less than 42, and For this here it is 50. For example, this is the binary search tree. This is the binary search tree. For this, how can we calculate balance factors and check whether it is an AVL tree or not? Okay. So now, so what I said, so for leaf nodes, balance factors directly write down 0. For 45, what is the left subtree? This is the left subtree. Left subtree height is 1. There is no right subtree, 0. So 1 minus 0, here it is 1. Next for 40, so no left subtree, so assume it as 0. Right subtree means it is not like this. Okay, see, this is entire right subtree for 40. So this right subtree height is 2. So that's why here 0 minus 2, here it is minus 2. So at node 40, the balance factor is minus 2, which is not an AVL tree. You can stop here and you can conclude that this is not an AVL tree. Okay, so but for practice purpose, I am explaining the balance factor calculation at node 49. At node 49, so now for 49, this is the left subtree. In this left subtree, what is the height? 1, 2, 3. 3 minus right subtree 1. 3 minus 1 equal to 2. So at node 49 also, the balance factor here it is 2, which is property is not satisfied. That means AVL property is not satisfied at node 49. So it is not an AVL tree. So like that, you can find out whether the tree is balanced or the tree is an AVL tree or not. Okay, observe carefully what we have discussed. So what is the need of balancing the binary search tree? Now, how can we know that whether the tree is an AVL tree or not? These two things we have discussed. In the next video, we will discuss so how to balance. Now we identified the tree is not an AVL tree. So in the next video, we are going to discuss how to balance, how to convert the unbalanced binary search tree into the balanced binary search tree. That is our next video. So how to apply rotations, all these things we will discuss. So hope you understand, students. So if you like the video, if you understand the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.